Hey, my name is Sean Kavanaugh. I'm a technical marketing engineer at Red Hat that specializes in Ansible automation, specifically Ansible Network Automation. Today we'll be covering 5 great use cases with Ansible Network Collections. And although I'm recording this ahead of time, I'm sure I will be cringing at myself in the chat room. You can ask me live questions, or you can always hit me up on Twitter or Slack. So my handle is IPVSean, which I should have put in the slide. But, oh well, let's go over the agenda. So we're going to talk about an Ansible Collections, obviously, today. There's some expectation you know what that is, but I'll briefly cover it for those who are just not familiar with what a collection is and why you should care. We're going to talk about installing an Ansible Network Collection, how easy that is to do, and then I'll go over 5 quick use cases that I think are important to think of holistically that will help folks kind of think about how to approach network automation problems. And again, I always say the theme for network automation or automation in general is small incremental steps where you get wins, because you're not going to have a successful automation journey for your group, company, enterprise, unless your whole team is on board and doing it. So if you start doing automation and you do all this automation, no one can understand it, that's the whole purpose of a tool like the Ansible automation platform. So let's get started. So what is an Ansible collection? It's just content. So previously, you would have seen kind of marketing nomenclature around Ansible automation as batteries included, where you just did pip install Ansible or yum install Ansible, and you just got everything. And it was just one giant blob of everything together. And that was really nice. However, it made it really difficult for folks when they tried to upgrade content. For example, let's say there was a Cisco iOS bug and this particular module wouldn't work. You had 2 options. You could update to development and get the newest release, or you could wait. So your kind of options were kind of 2 unsupported options. Like one, you're going to have a bug or something not working until the next release, which could be 3 or 4 months away, or you were moving into the development branch, which could break other things that were unintended. So we basically modularized content being Ansible playbooks, roles, modules, plugins. So think plugins like a filter plugin, just changing like JSON to YAML or YAML to JSON. That could be a piece of code that's included within Ansible content. So if you're from the developer background, you can kind of think of it as this giant Python library that you can just load in. And that kind of changes it out from the base. So the base project, the Ansible executable, is no longer tied to specific content. So this allows a much more enterprise solution for people trying to do automation. So how do you get content? Where do I get it? I think most people familiar in the IT industry are familiar with Red Hat Enterprise Linux, and they're familiar with Fedora. And that's kind of their first foot in the door with open source software in general. So we've done the same thing with Ansible Galaxy and Automation Hub. Galaxy is the upstream, it's Fedora. This is where you get community supported code, it's fast moving, the newest is always up there. And then Ansible Automation Hub, this is where we get joint certified content. So you know that you're getting stuff that's going to get support, throat to choke, hand to shake. This is the stuff that people want when they're in enterprise. So you can go on vacation, you can move job roles, and you're not tied to some automation code you wrote 5 years ago, right? This is standard supported automation. And you can kind of see this problem if you'd ever used some of this stuff in the past is you want an Nginx role, and there might be 50 to choose from. How do I get the one that's certified and supported for my particular use case? And that's the difference between Galaxy and Hub. Everything is still open. It's developed open. Our partners do a lot of stuff in the open. Everything we do at Red Hat's in the open. But when you want that certified content that we roll out in a release, that's Automation Hub. And either way, you can kind of get that content. So how do I install it? This is super, super easy. Ansible-Galaxy, which is included when you install Ansible. So if you did a yum install Ansible, you would get this executable command, Ansible Galaxy collection install, and then the collection name. In this case, the namespace is Cisco, so I'm just talking about a network automation collection. And this particular collection is iOS, so it's namespace.collection name. And this will default install into your home folder. And I just put that in there just for folks to know, like, where does this content actually go? when do I get to use it? Can I look at what it installed? And that's kind of where it places it in your home directory under .ansible collections, Ansible collections. And of course, you can pin these. So if you want to pin to a particular version, that's an easy thing that you can do. In this case, since I did not put a version number in, it's just going to pin to whatever the latest release is. So now that you know what a collection is, an Ansible collection is just content. Content is just modules, playbooks, and roles, and installing it is just one command to install that collection and start using it. So some of these playbooks that I'm showing in some of these use cases are going to use the fully qualified name. I could add a few slides just for brevity. I'll make sure that I put tons of slides online that go into more detail, but just because I know people are burning out from virtual events, we're going to keep this talk under 30 minutes. So I didn't want to get too far into the weeds with collections when we really want to talk about use cases. So the first use case that I usually hear customers talk about is backup and restore. And while this isn't that cool or interesting, it's a very kind of foot in the door use case that people start their automation journey with, is they're just trying to automate away a very boring routine task that they don't want to do. And yes, there's plenty of tools that do this besides Ansible automation, but I think it's at least worth showing how easy it is with Ansible automation and what you can do with the platform versus having to create your own little Python code that goes and does this on its own. So if we have a Cisco box, an Arista box, a Juniper box, no matter how I call those modules, the experience is very similar. So in this case, each of these modules just has a backup parameter, and then we just put true. You can also put yes. Of course, any kind of YAML syntax works here, but these modules are super easy. That's it. So if I had a role written that called these particular tasks, each of these being an Ansible playbook task, I can back up hundreds of different network devices, super easy using Ansible, and the experience is the same regardless of the platform. And here I chose 3 very different platforms. It could be argued Arista and Cisco command lines are very similar, but especially with Juniper, right, is those are completely different syntax commands. So this allows your operators and your network engineers to kind of open up more opportunities so that they're not tied to a specific vendor. And it also makes it easy for that automation knowledge to transfer between vendors. So you're not wasting a lot of OpEx time trying to figure out how to reinvent the wheel each time you do automation. So just like we can do backups, and one of these kind of got returned there in the Cisco example, just with slides going back and forth. But just like we did backups, we can also restore. You see, I cleverly scratched out backups here. I'm just trying to show that that experience is very similar with restoring configuration, meaning loading from a backup back onto the device. It's a very simple use case. You'll see there's a couple parameters different just because those network platforms have slightly different ways and options when they load configurations. So there's sometimes some syntax issues just slightly, but that's just when there's a specific feature that we can take advantage of. We can do that with the modules. It doesn't mean it's that much harder. And then obviously all this module documentation is kind of self-documenting within Galaxy and Automation Hub. So something I always like to talk about too is folks ask me like, what's the platform do to this versus command line Ansible? And when you purchase the platform or you use any of the open source equivalent tools, you can get things like surveys. So you can kind of elevate the task you did. So you take a playbook you wrote, or you just use mine and grab it from Galaxy. You take this backup and restore functionality, and then you can make it really turnkey and easy for any engineer to kind of load from backups. So in this case, every time I do a backup, it populates a survey within the Ansible automation platform, and then you can self-select where I want to restore to. So if I show up at the work and the network's borked, I could just be like, okay, nuke from orbit, let's restore from 2 days ago, and then just press a button, and then it takes care of loading that configuration back onto the devices, and then you could specify which devices. And then this is all within a nice, cool web user interface. So you just load it in a website, and you just click launch, go, and all the Ansible stuff's happening underneath that you already automated away. All right, so first use case, backup and restore, super easy, pretty common. A lot of folks' first foray into Ansible automation is just doing a backup. hopefully folks are still interested. It gets more interesting as the presentation goes on, and I'm sure I'm answering questions as things go on in the chat room, so feel free to keep asking questions. So fact collection. I think a lot of folks who are familiar with Ansible know about facts. So for folks that aren't familiar with Ansible, or is this your first foray, because this talk is meant for all folks, not just experienced network engineers that have done Ansible automation for a few years now, is facts are just structured data that we get back from the device. It's just what Ansible calls information. So an IP address for an interface, that could be a fact. The MTU of an interface could be a fact. The host name of the device could be a fact. Like anything from that device is a fact. They're key values, pieces of information that are stored in structured data, YAML or JSON in our case. So, fact collection. Sorry, I just heard a sound and I was getting distracted. Is basically, you can do facts and grab everything using built-in facts within Ansible, but I kind of want to talk about resource modules, which we've released a ton about. And if you're going to any other network engineering talks, you're going to hear a lot about resource modules. But resource modules are very nice because they make this very easy to take configuration and move it into something that we want, which is structured data, which then we can do cool things with. So 3 of the parameters for resource modules are parsed, gathered, and rendered. And rather than read from this slide, I'm just going to show you some examples. So, parsed. So if I use a resource module, for example, a resource module iOS L3 interfaces, this resource module configures L3 information, meaning IPv4 and IPv6 addresses on interfaces for devices. In this case, iOS prepends it, so you know this is for Cisco iOS operating system. The parsed is really cool because I do not need connections to actual network devices. I'm going to take a flat configuration file. So I placed this slide after the backup just to show this because we already have backups of our configuration now. Now I'm going to transfer that backup into structured data. In this case, it's YAML, but YAML and JSON are basically the same. I know people will argue with me that there's nuances. But in this case, just for slide brevity, I put it into YAML. And it transfers this without a connection. So I can take flat configuration files, parse them using the interface, and then see what they would look like rendered into JSON. So each resource can do this. You can do this for VLANs, L2 information, interface state information. Any resource module that exists has these same parameters, and parsed is one that works without connections to those actual network devices. So gathered, this is where we're actually retrieving new information from that device. So the network native configuration, native meaning like the way you would see it if you did a show running configuration on a Cisco box, is going to be converted to structured data, and then we store that as JSON YAML. So this is an actual playbook example. On the left is actually a holistic playbook. It's only 2 tasks. So this playbook, it only runs on the group or device named Cisco. So this could be 100 devices named Cisco. I turn off the native gather facts because I really just want to grab info for the specific resource module. So in this case, I'm going to grab information from L3 interfaces. Again, I'm using the iOS _ L3 _ interfaces resource module, and the Cisco.ios is the namespace .collection. And then I'm just doing gather. Just gather information and show that to me. So debug, that's just going to print to the terminal window. So in this easy example, I'm just printing it back to a terminal window. In the Ansible automation platform and the web UI, you would see that in the browser window. But more realistically, you'd probably want to save this off to a database or turn it into a website or something usable for yourself. But just for testing, I just show debug so you can, like folks watching this talk could just cut, paste, put it on their network, and then see it right in the terminal window without having to know anything about HTML, Markdown, or anything else. So you'll see this just takes that same configuration and it transfers it. This is different from parsed because this is actually connecting to the device and grabbing it. So really quickly, you can imagine if I built a report, I could schedule this playbook to run maybe, I don't know, once a day, once an hour, and just kind of do diffs to see, like, did someone go in there and change a resource on this? And then do I want to revert back to like my golden master, my standard configuration? So rendered is kind of the opposite. Is what we're going to do here is take that structured data and we're going to render the configuration, but we're not actually going to place it on the device. That's going to be more config management, which I'll talk about in some later slides. So we take that structured data and then we transfer it to the actual device configuration. So it's the exact opposite. Is it's going to tell us what it looks like rendered on that device. So a practical example is it's going to show us the literal commands a network operator would type given that. So in this case, I'm going to take the config that I got in a previous slide, I'm going to render it out and then display those commands. So for folks unfamiliar, these are Cisco iOS commands that an operator would type. They would be like configure terminal interface loopback 0, IP address 192.168.1.101, and then the subnet. So this is just rendering those device commands and showing us exactly what would be typed. So it's super cool, it's super interesting because now we can do some rendering before we actually connect to that device. So again, kind of go back a few slides. Let's just think of those three. Parsed does not require connection. Gathered is getting it. It's kind of like a fax, but we can do it right within the module. And then register that. And then rendered is kind of doing the opposite, where we're rendering commands from a configuration to show what we would do. Now rendered is not taking, it's different from restore because it's taking it from a source of truth where it's already in a structured data, right? So rendered is expecting structured data in YAML, and it's expecting it in the way we want it. So like our specific config schema, which each of the resource modules has well documented as the schema for that specific resource. Schema meaning just the rule set, like the name and then the IP address, et cetera, et cetera. So it's super simple: parsed, gathered, rendered. And I know those might be new to folks because they're fairly new to resource modules. So we're going to now get into the third use case. First use case being backup and restore. Second use case being retrieving information, right? And then I kind of added some additional ways to kind of get that information and parse it from back and forth from plain text, like Cisco iOS native configuration back to structured data and back and forth. So config management kind of takes that to the next step, is how do we start and enforce that policy? How do we deal with drift? This use case is where network teams want to get to. So when we talk about managing infrastructure as code or networks as code, what they're talking about is DevOps config management. So once we have a source of truth meaning somewhere that's our golden master, our configuration rule set, where everyone has agreed that the IP addresses are stored. So your configuration source of truth could be a ServiceNow CMDB or Infoblocks or a NetBox or a proprietary database. It doesn't matter. As long as everyone on your team agrees to it, Ansible can pull from that. So I have a very simple example here. We're going to assume we already retrieved the data model, like in the previous example, or we just made it from scratch. And then we're going to merge this configuration into our network device. So in this case, my data model, my schema, IP address info in the top left, I have two IP addresses, loopback 100 and loopback 200. You'll notice me just using loopbacks because I use a lot of virtual devices on the public cloud. So just for testing modules around and everything, it's just simple to have tons of little virtual interfaces to kind of be testing and doing examples with. So in this case, the default merge here is state merged. And what this is going to do is it's going to actually load this configuration onto the device. And now what's not covered here, just for brevity, is this is just merging this data model into the running configuration. So if I already had an IPv4 address, and this particular device allows more than one IPv4 address per loopback, it would just add that additional IP address on. It's not going to remove the other one. Hopefully that makes sense to folks, and I can kind of go over that in the questions if that's confusing. But this is just ensuring this data model exists on that network device. It's not removing anything existing on that network device. So just like we had different state parameters before, these are the other four. So there's a total of 7 state parameters. So we have merged, which is the default, where it's just merging the configuration from your data model back onto that network device. Replaced is going to replace the data model on the device. So this will actually remove IPv4 addresses from the device for each of the resources. Now, overridden takes us a step further, is if you don't specify something, it's going to remove it. So if I only specified loopback 100 in that previous example, it's going to remove all the other loopback addresses. So overridden's a little bit more powerful. And then deleted's the easiest, is this is just removing the configuration that you specified. So the way I kind of think about this at a high level takeaway, I don't expect anyone to memorize all these parameters, and they're documented on every single resource module, is I kind of think of the journey of config management as we start kind of like with backup and restore, and we start getting information out of our network with retrieving facts. And then what folks do in config management is they start here with merged, and then their automation journey kind of moves down the stack, where it goes from merged, and as they gain confidence with the automation, they move on to replaced. Meaning, what this will do is if there's a bespoke change, like a network operator goes into a closet and he adds an IP address for like a quick fix, replaced is now going to remove his configuration every time an Ansible playbook goes through that device. So this is where we talk about policy drift, is our policy slowly becomes that source of truth as we begin to trust it. And then as my team's culture moves towards automation, we move to replace, and we can start enforcing that configuration policy, meaning the golden states, the configuration we've all agreed to as a group. And then it starts removing configuration and enforcing that configuration state on those devices. Then overridden is just taking that further, where like you won't even allow another interface or anything else to be, anything that resource module knows about, it's going to remove unless you've specified. So this is kind of your journey of maturity, for lack of a better word. I'm sure I'll come up with a cooler one in the chat. You'll see me making fun of myself. Future Sean is mean to past Sean. So merge, replace, overridden, just think of that as kind of your journey. So each of the resource modules here also includes return values. So you don't need to do like that render commands. You could just save off the before. The before is the data model of the device before we started doing a change. Commands, again, are kind of like rendered, where it's showing the literal commands, like IP address, whatever. The command would be on a Cisco iOS device or an Arista device or a Juniper device. Then after is just showing us the data model after we configured the device. So you get a before, the commands you did to get to the after state, and then you get the after state. And the before and after state are not flat file configs, they're the structured data. So let's keep taking this idea of like your maturity to infrastructure as code or networks as code, or this idea of just treating the network just like we do servers, and folks have this DevOps model, is why don't we just keep going into the fourth use case, creating a source of truth. So this is how we get to managing the network this infrastructure as code way. We want folks, instead of people memorizing configurations, this hopefully nullifies use case one, is what I'm trying to say, is you don't look at backups as being as important. You care more about the source of truth. The source of truth meaning like, I agree with my friends that the IP address on these devices should be 10.10.10.1, and this is the source of truth for that, because no one's going to memorize all IP addresses for my 10,000 switch network. So let's go into this use case. So this is not hard conceptually. Is we just take that same idea of transferring this configuration using resource modules. Is we take that native network configuration, we convert this to structured data, but now we're going to do something with that data. Is we're actually going to store this in variables. Variables meaning structured data that Ansible uses to configure. So basically, we're going to persist this information that we're getting from facts. We're not just going to load it into a website. We're not just going to load it into a database. We're going to make sure it's stored some way that Ansible can use that. And that could be a database or a website. But we want to make sure that we're storing these as host vars when appropriate, or group vars when it's appropriate. And it's very, very, very simple to do this. And this is kind of the nirvana folks want to get to for infrastructure as code, is they want to be able to read in brownfield networks, transfer this into structured data, and then that becomes what people care about. You're no longer going on manually to individual switches and making network configurations. You're going to start managing this from a central repository. So some teams choose to do that in a Git model where they're doing pull requests to GitHub or GitLab. And some teams prefer using some sort of CMDB or like an IPAM, IP address management tool like Infoblox or Netbox. And really, I don't think there's any one clear winner in this case. I've seen huge amounts of folks use GitOps as their entire model. They do everything as infrastructure as code. They don't find it that hard. And I have other teams that are almost religious about this, where they prefer some sort of web UI like Netbox or Infoblox to manage everything. And I would say my only opinion here is make sure your team is all on the same page. Otherwise, you end up with multiple sources of truth. And you probably see all kinds of talks about this where there's this culture problem, not technology problem, and that causes problem where if you have two or more sources of truth, you don't have any source of truth. So it becomes kind of like this unfortunate battle where automation just can't win culturally because you're just not having people use the same tools. So I hate to have any tool argument except Ansible. Obviously, I'm an Ansible diehard at Red Hat employee, but I would say just agree on where you're storing this. It could literally just be a flat file somewhere. It doesn't have to be overly complicated. You just have to make sure that it works for your use case. So in this example, I'm going to grab all facts. So you could do this with gather facts true. I don't have that example here, probably because I stole this that existing, meaning that we added that feature in. So I'd have to go look at an example. But this is easy enough. If I want to grab all Cisco facts, I can just use the cisco.ios.ios facts. And then I have this gather subset min. This is to be backwards compatible with older versions of Ansible. This will eventually get deprecated out, but I'm just explaining why it's not just why there's those two parameters there. And then gather network resources. This is a new parameter as of last year. And if I just put all, it's going to grab every resource module that exists within that Ansible network collection. So if there's 50 different resources, all 50 resources are going to be stored back. And then what I can do is just with the copy module, I can move that from in memory and then store it as a persistent flat file. And then really, I don't care after that. This is where I said it gets into that kind of tool argument, is I can move that file or information into a database or do a git commit. It really, really does not matter at that point. But what you want to do is just this, is just make sure you're moving it somewhere. And you can see I did two nice YAML just so it's super easy readable for myself. And that's it. You got all these resources. And then you can just cat that file. So here I'm just cat meaning just look at this file for those not familiar with Linux commands. And you can see there's the interfaces key and all the interfaces for this device and the VLANs key and all the VLANs configured for this device, and it goes on. And if the resource is empty, it's showing up in white font, unfortunately, but it says LACP resource is just showing empty. It's just a dictionary, meaning it's an empty dictionary of two parentheses where it's showing there's just nothing in it. So there's nothing going to be there. So last use case, and I promise I will be done soon, is third-party integrations. Is once you have this idea of infrastructure as code, like automation is really cool, but it's not interesting to business developers and your business. Like I always make this storytelling of, like, my wife is a very technical user. She's a pharmacist. She's very smart, well-educated, uses all kinds of IT tools, but she does not care what network switch vendor that it's running on. She doesn't care what vendor her laptop is as long as it works. So we got to think sometimes it's not just that Ansible is great, but that it interacts with all these business tools that matter to the businesses and how they make revenue. So in this case, I just want to show like a very simple outline. Unfortunately, I guess a couple of things got converted down, but it's readable, and I'll provide this image later. Is you interact with the platform as the central orchestration unit. You see Ansible there in the center. So your inventory could be stored in ServiceNow. CyberArk could be your credentials. Your pull requests come from GitHub, and we do API pull requests. And this configures network devices. And I kind of see the three categories of these being where we automate the automators, where we automate something like Cisco NSO or ACI, where we interact with cloud services, and when we automate kind of platforms like ServiceNow ticketing or something. So there's a bunch of different ways to think about this. And it's important that you interact with these tools. So I really appreciate it. Thank you for attending this talk. I really hope folks go onto the network documentation page and join our Slack group. We have an ansiblenetwork.slack.com that you can join. And our YouTube channel, I'm going to put more and more demos up there on youtube.com/Ansible Automation. I really appreciate everyone attending. Thank you and have a great day.